Hello everyone, welcome back to CSEC Math Prep. We are now on to our 1, 2, 3, 4, 5, our 6th video covering all 10 questions in preparation for CSEC Math Exam. Okay, we are on to measurement this time. And without further ado, so we're doing 5 questions from measurement, and this is our first question. All right, so here we have a situation with a compound figure. In diagram below, not drawn to scale, represents the plan of a floor. The broken line RS divides the floor into two rectangles, A and B. And the first question said that we should calculate the length of RS. Now, RS is this distance right there. It's where these two floors, part A and part B meet. We want to calculate the length of that. Now, part B and part A are both sharing that RS length there. But if you notice, the base here we have as 8 meters. And if you want to find RS, the simple thing, we just subtract the 2 from that 8, because part B is a rectangle, just like part A. So both lengths are the same. So when you subtract the 2, that's part of the length there. From 8, we get that RS to be 6. That's it. Now, hence, state the value of X, and that is another length that is a part of rectangle A. Since the length for that rectangle is 10, that answer that we just got from part A1, 6, when we subtract it from the 10, we get that X value to be 4. Easily done. Part B of the question, calculate the perimeter of the entire floor. Now, perimeter is the distance along the border of any figure. So if we just add all these yellow lines there, along with the distance for the green lines at the top and at the bottom, then we get the perimeter. What we're going to do is exclude that 6 there, since it's not along the border of this floor. Right, so we have, when we add all those, we get 38 meters, and that's a perimeter for the entire floor. All right, now part D of the question, right, is asking, part C is asking for the area of the floor. All right, part B was for the perimeter, P, good. Now, all we do at this point is separate that floor into two parts, A and B. It's already separated, but they are both rectangles. So for part A, it's 5 times 10, the length times the width, that's 50 meters squared. And part B is length times width again, 3 times 8, 24 meters squared. And entire floor, therefore, will be 74 meters squared. All right, I don't have my square unit here, but it should be there, right? 74 meters squared. Good, that covers part C, area of the entire floor. Then part D now, what we have is section A of the floor is to be covered with flooring boards measuring 1 meter by 20 centimeters. How many flooring boards are needed to cover for covering section A? All right, so the flooring boards for section A there, right? Let's say we have some boards here, 1, 2, 3, covering. The question is asking how many of these, right, will be needed to cover all of section A. All right, the area for section A, we have 50 meters squared, right? And we want to cover the flooring boards measuring 1 by 20 centimeters. Now, if we use our little conversion listing, from the smallest unit for measuring length, millimeter, down to the largest, right, kilometers. From when we're converting from a unit above that we have here, like from millimeter going to any other units down, we're dividing. So since we're converting from centimeters, right, down to meters, we're going to be dividing by 100. So anytime you want to convert centimeters to meters, we divide by 100. That would make the board a 1 meter by 0.2 meters. So we had to convert a centimeter to meters. So the width would be not 20 centimeters, but we're going to be using 0.2, and the length is 1 meter. So we have our units in meters. So the area for one board will be 1 times 0.2, which is 0.2 meters squared. All right, so how many of those boards now would cover floor A is 50 meters squared divided by the area for one board, 0.2 meters squared. So we need 250 boards to cover section A of the floor there. And that's it for this question. Just basic concepts in terms of area and features of a rectangle. Good. Question 1. All right, so let's move to the other question. Here we have another solid A, B, C, D, E. Is the cross section. There's some information above there, and we're just skipping through. So F is the midpoint of EC, and BAE is equal to CBA, equal 90 degrees. So we have vertical lines there meeting at AB on our solid here. All right, the first question is asking us to find the length of EF. The question already states that EF is halfway EC. All right, so what we're having is that EC is part of a rectangle, AECB. So it is the same length. EC is the same length as AB here. So half of that would be 3. So EF would be 3 centimeters. All right, so that's a given. Part 2, DF, which is this length here, is what they're asking us to find out. Now we know that C is 3. So to find DF, we have to apply, since it's a part of a right angle triangle, the Pythagoras theorem. Now, it so happens that DF is one of the shorter lengths. And if we know Pythagoras well, we know that we're going to square the two short sides and equate it to the longer side. What we're going to have is 3 squared plus x squared equal 5 squared. 5 squared in that situation is the hypotenuse. So we have to equate the square of the two short sides to that side squared. So what we're going to have is 9 from 25. All right. Here's another error here on my diagram. So at this point, where we have this 25 squared minus 9 squared should be 25 minus 9. The square should not be there, right? And then we'd end up with 16. When we square both sides, x would be equal to 4. All right, now for the last part now, the area of face A, B, C, D, E. Now, I'm just highlighting a little clip from the first part of the paper where they have the formulas. It says area of triangle, which is half base times height. All right, so what we're going to do is we're going to find the area for that section of the diagram, the triangle. We know the base is 6, and half of that is 3. So 3 times 4 will give us 12, or 6 4 is 24 divided by 2, which is a half of the 24 would give me 12 centimeters square. So that would be the area for our triangle at the top here. And then what we want to find out is the area for our rectangle here. It's length times width. Now we're seeing the length at the bottom to be 6, but where is the 5? The 5 is actually at the other end of a solid, which is the same height. So it's 6 times 5 will give us 30 centimeters squared. So the area for that full face, A, B, C, D, E, will be 12 plus the 30, 42 centimeters squared. That completes this question. All right, good. Moving on to the other measurement question. So one with solid and another question with just plain shapes. All right, now we're having a situation now where no diagram is shown in this case. All right, let's get rid of part A first. Part A is algebra, solving inequalities. All right, let's get that. So we have 5 minus 2x less than or equal to 9. We want to let the x be on one side all by itself. So we're going to subtract 5 from both sides. And we're going to have with minus 2 less than or equal to 4. Dividing both sides by 2 by minus 2, we end up with x greater than minus 2. Now there is the principle that we should remember, that whenever we divide both sides by a negative number when doing inequality, the sign will turn the other way. So it's less than there. So it's going to become greater than in our final line here. All right, now the question is asking beyond, if x is an integer, define the smallest value of x that satisfies the inequality. Now, integers are all our positive and negative numbers, and the values of x, given that it's greater than minus 2, would be minus 1, 0, 1, 2, 3, on and on and on. But the smallest one is what they're asking for, which is minus 1. That completes that. All right, so let's go on now to part B, which is our measurement question. And they're giving us, for this question, pi to be 22/7. That's what we're going to have to be using here. A piece of wire is bent to form a square of area 121 centimeters square. Now, let's say this is our piece of wire, and it's bent here to form a square, and its area is 121. Because it's a square, x squared equal to 121. So let us say one side was x. You multiply it by itself, length times width for the area, 121. If we want to find out what one side is, what we'd have to do is square root that 121. And then x will give us to be 11. And that's the side for 1. That's the length for one side of our square here. The next question is asking us the perimeter for the square. Since we know that one side is now 11, then the perimeter for our square would be adding all these sides, giving us 44 centimeters. And that's our perimeter for the square. 3 marks for those two parts there. Finally, the same piece of wire is bent to form a circle. Now from our perimeter for the square there, right? We know that the length for this piece of wire is now 44 centimeters because it was the same perimeter that's used. And it's now used to form a circle, right? Now, the part of the circle that we're seeing here, its length is 44. That's its circumference. And what we want to find here is a radius for the circle. Now, if I should pull up that section of our formula sheet that's already on the paper available to us, we can now look at that first formula there. C equal 2 pi r, that is circumference. Now, all we need to do is apply that formula and equate it to 44 since we already know what the circumference is. Now, the only unknown in this expression here is our r. Because remember, they gave pi to be 22/7. So it's 2 times 22/7, which is pi, times r equals 44. Now, if we should simplify further, we could multiply 2 by 22. And we have 44/7. R equals 44. If you multiply 7 on both sides, and then divide that answer by 44, or for some people, they say 44/7, we'll flip on the other side, right? Giving us R equal 44 multiplied by 7/44. And 44 will cancel each other, and R is equal to 7. So our radius will be 7 in that case. And that would complete this question here. 154 is our answer. All right. Congrats for keeping up. We have just 2 more questions to go. These are concepts that you will see for sure, even if it's on the multiple choice paper and not paper 2. You can't miss these concepts. They are the foundations for measurement, right? All right, moving on to yet another question. And here we have our circle again. But this time, it's not a full circle. The question says, the diagram below not drawn to scale shows the cross-section of a prism in the shape of a sector of a circle. Center O, radius 3.5. The angle at the center is 270 degrees. Now, pi is giving us 22/7 again. And they ask us now, calculate the length of arc ABC. That's our curved part there from A coming around to B going back up to C. Now, Let us say you don't know from memory the formula. Remember, we can pull from our formula sheet. Our second formula there says arc length. It's angle over 360 times 2 pi r, our circumference, right? You can always just pull back for that and then use those in your answer. Now, the question above, the information above gave us that the center is 270 degrees. So it's 270 over 360 multiplied by 2 times pi times r as it was given right here, right? So 270, if you should cancel 90 both at the top and at the bottom, will give us 3/4 times 2 times pi times r. Now 3/4, 2 times 22 is 44 divided by 7 multiplied by 3.5 will give us 22. In fact, I don't have my cursor here to show you, but 3.5 can go into 7 2 times. And then the 2 would cancel the 2 beside that bracket there, leaving us with only 22. Please use a calculator to ensure that my answers are correct here. All right, so our final answer would be 3/4 times 22, which is 16.5, and that would be the length for our arc ABC. Remember, we're just applying some numbers to the formulas, right? So we don't have to go in the exam and lose the mark for this. Let's just apply the formula and present our answers. All right, part 2 of A, the perimeter of a sector AOABC. All right, now perimeter is the distance along the border of any shape, right? We already know that the curved part ABC is 16.5. The only additional lengths that we need, right, is these two parts here. That part, which is 3.5 each. So it's 16.5 plus 3.5 plus another 3.5. And our perimeter for the whole shape there would be 23.5 centimeters. Good. Now the area for the sector is what they're asking for. And just as it was with the using of the formula sheet, we can of course pull it up again. Remember, now students, for this, we can just skip back to the front of the paper, look at the formula sheet. All right, so we're looking at our final, at the last formula there, angle over 360 times pi r squared this time, since they're asking for the area. All right, so you and I know that the angle is 270, right? 270 over 360, and you're multiplying it by the area, which is pi r squared. So it's 22 over 7 pi times 3.5 times another 3.5. So it's 3/4 times 38.5 would be the result for pi times r times another r. And then our final answer, 28.9 centimeters square would be the area for sector AOB. Okay, good. Again, part B is asking for the prism is 20 centimeters long and the solid is made of tin. Calculate the volume of the prism. So it's asking for volume. Even that is given on our formula listing, right? And it's the first one there, V equal AH, where A is the area of cross section, which would be the area of our sector. In this case, we have already found the volume to be 28.9. So it's 28.9 area of the cross section multiplied by 20, which is the length of the tin that they just mentioned below, right? The prism is 20 centimeters long. So our volume is 577.3 centimeters cubed for volume in terms of unit. And that covers that. And then now part 2 of B is saying the mass of the prism to the nearest kilometer, given that 1 centimeter cube of tin has a mass of 7.3 kilogram. So 1 centimeter cube is 7.3 kilogram of a tin, right? But according to our volume, there are 577.3 cubes of tin. And each of those, right, weigh 7.3 kilograms. So when we multiply those, we'll get our answer to be 4,215 kilograms in terms of weight, right? And that completes this question. Take your time, go back through the question again, and familiarize yourself with how the formulas can be applied to get to your final answer. All right, very good. On to another interesting question. Now, this is map reading, and it surrounds the idea of scaling, right? Now, it's not difficult. Let's look at it in steps using the map. Oh, it's always important to read the information above at the beginning of each question, right? So the diagram not below drawing the scale, the map golf course drawn on a grid 1 centimeter square. The scale of the map is 1 to 4,000, and we're talking about centimeters. So 1 centimeter on the map is 4,000 centimeters on land. Using the map of the golf course, find the distance to the nearest meter from the south gate to the east gate. Great. So from the south gate to the east gate, we're talking about 1, 2, 3 centimeters on the map, right? South gate to the east gate. But 1 centimeter is how much again? 4,000 centimeters on land. So the distance from south gate to the east gate will be 3 times 4,000, which is 12,000 centimeters. Now, they want the distance on land, and they set in to the nearest meter. That means the 12,000, you have to calculate it now to convert it, to meters. Again, if we list the units of measuring length in metric from the smallest to the largest, whenever we're going down, we're dividing. So from centimeter to meter, we're dividing by 100. 12,000 divided by 100 is 120 meters, right? That's from the south gate to the east gate, 120 meters. All right. On to the next question. The distance nearest meter from the north gate to the south gate. The north gate to the south gate, talking about this distance here. Now, if you notice, we are on grids, right? Therefore, we can apply the concept called Pythagoras theorem to this question here. Should be readily seen by many, especially trigonometry is your favorite. Now, we can apply Pythagoras to this, and it's 5 squared plus 3 squared equal to the side that we're looking for, in this case, the longest side, x squared. 25 plus 9 equals x squared, and we're going to be adding those and find the square root of both sides, giving us x to be 5.8. CSEC seem to love the idea of 5 squared, 9 squared, 4 squared. So let's really get used to those square numbers there, and all of them to the square of 12. So 5.8 squared is the length on the map from the north gate to the south gate. But what they want is the distance in meters, which means on land. So what we're going to do is multiply 5.8 centimeters times 4,000, giving us 23,200. But that's centimeters. And then and therefore we have to convert that again to meters by dividing by 100. There's 232 meters from the north gate to the south gate. All right, on to our third part of the question. The area on the ground represented by 1 centimeter square on the map. Now we're talking about one little box. 1 centimeter square box. Now, on the ground, what we're going to do here is 4,000, right, is the length on land for 1 centimeters. So what we can do is convert these 4,000 to meters and then square them. So again, we just divide by 100, giving us 40. If we divide one side and then multiply 40 by another, what we have is 1,600 meters square on ground, right? So that's what 1 centimeter square is representing. Finally, the actual area of the golf course, giving your answer in square meters. All right, so what happened is 1 square alone is 1,600. Now, this, we're going to apply counting of squares in this question here to get an estimate of that. So we have 1 square there, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27. And how we apply this is that you count the squares that are more than halfway covered by the golf course. Those that are not, we just exclude those. So it will be 27 now, multiplied by the area for one of those squares. And therefore the area for the whole golf course in meters would be 43,200 meters squared. That completes our question. And we're off now to our final question in measurement. See? Easy. A company makes cereal boxes in the shape of a right prism. And our dimensions are given 25, 8, and 36. Each large box has dimensions as given. Calculate the volume in cubic centimeters of one large cereal box. Now, I've already mentioned in a time past that volume is area of cross-section times length. So this part of the box here on the ground is the cross-section, which is a rectangle. So the area for cross-section will be 25 times 8. But we have to multiply by the height now to get our volume, which is 7,200 centimeters cubed. That's our volume for the large box. Some people would say length times width times height. Fine, nonetheless. All right, second part of the question. Say, calculate the total surface area of one large cereal box. Now let's concentrate now. This is a box with what? 1, 2, 3, 4, 5, 6 sides. Now let's start with our base face here. That's 25 times 8. But it also has a similar face at the top, right? So it's another 25 times 8, 200 centimeters square. So we have our bottom face and our top face here for this solid. Now, we have the side face here. That's the height is 36. That means our length for that side face is 36 and the width is 8. So that's another side face over here that's similar to it. We have 36 times 8, 288. We have just two more faces. We have the front face right here, and we have another face at the back, right? And that's 25 multiplied by 36. That's a height. And it's 900 in both cases because there's a face at the front and one at the back. And the total for those is 2776 centimeters squared. That's our total surface area. All right, very good. Moving on. The other part of the question, C, says the cereal from one large box can exactly fill 6 small boxes, each of equal volume. So what we have is 25 multiplied by 8 multiplied by 36. We know that that's the volume for the large box. And we are saying now that for the small box, 7,200 centimeters cube can fill 6 small boxes. So 1,200 centimeters cube is the volume for one of the small boxes. And then we have the others. So that completes C1. Part C2 now says, if the height of a small box is 20, list 2 different pairs of values which the company can use for the length and width of a small box. All right, so we know that the volume for the small box is 1,200. Volume remains the same for a cuboid. It's length times width times height, or area of cross section multiplied by the height. So the height is 60. So what we can do then is we're saying that length times width times height, which is 20 in this case, 20 multiplied by a certain pair will give us that 1,200. So since we know that the other part must be 60, so length times width times height times 20. We just need to find two pair of numbers that could give us that 60. So for example, 3 times 20 would give us 60 multiplied by 20. So that would be this 3 times 20 would be the area of the cross section, right? So on your diagram, where you have 20 times 8 would be 3 times 20, and the height would be 20. That would give us our 1,200. The company could also use a 4 times 15 base multiplied by the height 20 again, still give us 1,200. And these are just two examples, right? We could have 6 times 10 as well, which is 60 times 20. That would still give us that 1,200. What they're asking for really are these two pairs, right? Or it could be 10 times 60 or any other combination that you can think of. And that completes this question. The takeaway from this is that while doing the measurement question, take in consideration this. This is a blessing. So for most of the measurement question, if not all, we can apply one or two of these formulas here in ascertaining our answers. All right, that completes our measurement, 5 questions, and that will cover a lot, I believe, of whatever question is coming on our measurement section on the exam. All right, so moving on to those 4 more categories, right? And you would have been exposed to most of the questions that are coming on the CSEC exam. Until then, see you next time.